So we are going to do an angled projectile problem, right? Remember, any angled projectile problem, no matter what they're asking, the 3 steps we want to do is resolve the vector, break it down into its x and y, solve for time, then use time to solve for whatever you need, right? So this particular problem, let's say we've got somebody running on a rooftop, like in an action movie or something, right? And they're running at 30 feet per second, which is fairly fast for a person, but very reasonable speed that a person could run. It's 10 yards per second kind of thing too. So we've got 30 feet per second. They jump at an angle of 20 degrees. There is a 10-foot gap here and then another roof at the same height, right? So what we need to know is, are they going to cover an X distance of 10 feet, right? So first thing I want to do is break this down into its X and Y components. So to get our X and Y components, for the X component, right, I would do initial velocity of 30 feet per second times cosine of 20 degrees. And for my Y component, I would do 30 feet per second times sine of 20 degrees. You should do that and then try and move on without me too. So when we do 30 cosine 20, we get a Vx of 28 feet per second. When we do 30 sine of 20, we get a Vy of 10.3 feet per second. So then I would want to solve for time. Good idea to pause me and try and solve for time. I'm going to use y to solve for time because we're going to come up at 10.3 feet per second, then we're going to come back down at 10.3 feet per second. So I would use the Vf equals Vi plus At, all in the y direction. So I would say negative 10.3 feet per second equals 10.3 feet per second plus a negative 32 times t. Because we're in feet, not meters, so I would want to use the 32 feet per second squared, not 10 meters per second squared. So just rearranging some algebra there, 20.6 divided by 32 gives us a time of 0.64 seconds. Again, good idea to pause me and work ahead whenever you can, because I've got to keep the videos under 5, so I've got to go pretty quick. So I've got 0.64 seconds that he's going to be in the air. Velocity in the x direction is a constant, and it's 28 feet per second. So my displacement in the x direction would just be 28, would just be my Vx times t. So we just do 28 feet per second times 0.64 seconds, because that time can go in both the x and y direction. I am not going to use my acceleration of gravity in the x direction because gravity is not pulling you sideways, right? Gravity is pulling you down, which is why it's a negative here, just like the final velocity is negative, but my initial velocity in the y direction was positive. So we say 28 feet per second times 0.64 seconds. And what do you know, 18 feet. So he clears it easy, right? He's going to land 18 feet over here. So 10 feet, he has 8 foot of extra clearance, right? So made it no problem, just like Neo in the Matrix.